Welcome back. Hope you enjoyed completing the lab on joins and that you're now comfortable using them to join together data from multiple tables so that you end up with rows that contain columns from multiple tables. In this module, Module 4, we're going to talk about something similar but slightly different. So instead of talking about joining tables together in a single query, we're going to talk about unioning the results of multiple queries together. And to talk us through that, Jeff is with us once again. So Jeff, why don't you tell us what we're going to talk about in this module?
Okay, we're going to have a look at these union queries. We mentioned combining multiple queries into one, and we're also going to have a look at intersect and except, which are very much connected with unions. They're a subset, if you like, of union queries.
Sounds good.
So to start off with, union queries, logically, it's two queries or more than two queries. In fact, let's start with two queries. Mm-hmm. And we're combining the results, but not in the same way we do with a join, where we can have more columns of data. We're actually going to have more rows of data. So we say, okay, I want all the output from one, I want all the output from another one, and we're going to put the two, one after another, in the record set. So the example I've got here, we're going to have a look at employee data and customer data, because I want a list of all my contacts, whether they be employees or customers, as one list. So they're all going to appear here. We've got the country, region, and we've got the city, and we've got that whether they're an employee or a customer, because union combines the two. Now, it does say they're only distinct rows.
Okay.
It is possible we might have an employee who's a customer.
Right, yeah.
We can have employees who buy things from our company. I don't want them twice. I'm not really into, because I need a list of contacts. They shouldn't occur in my list twice. Mm-hmm. So therefore, it, by default, with just union, will remove those duplicate records.
So I get the same behavior as a distinct and a regular select statement.
Exactly, like a distinct, yep. So it's going to remove those excess rows. And that's why, so when I've drawn up the Venn diagram, they're touching, they're not overlapping there. It's basically saying they're separate data. If they were overlapping, it would get rid of you would only have one of those middle ones. It wouldn't have them twice in there. So John Smith is a customer. Is John Smith who's an employee? It would only display it once.
Right, okay, I see.
So that affects performance because it has to check. So it's got to check for every single row in one of those tables. It's got to check whether there's that value in the other one. So that's a not insignificant performance task for it to do, to go and make sure that that's not the case.
And of course, if I'm adding multiple union clauses for multiple queries, it's going to just get worse, because it's going to have to check right across all of them.
All of the different tables have got to check against all the other tables, so it gets worse and worse and worse. So we do have union all. So union all says, okay, I'm going to leave those duplicates in. So I'm not going to have that additional workload. I'm going to leave the duplicates in, and then I would see, oh look, I've got John Smith the employee and I've got John Smith the customer. They're the same person. I see them twice. It may well be that I want that as well. I want to know how many employees and customers I have.
So I may have a column that actually says whether this is a customer or an employee, and someone who's both should appear twice.
You say may have. I think when we do these, you quite often do. You have a literal column, so we would add in there to what we've got there is after the city, but comma, and then we'd put employee in speech marks as type maybe.
Right.
And we could have that. Otherwise, you don't know which one they came from. And it's quite useful to have that information. So then we get to a situation saying, well, if we had a scenario with the Venn diagram I have there, I know there's no duplicates, they don't overlap.
Right.
We cannot have an employee who's also a customer. They are separate entities. I need to treat them, and if there is such a case, that I need to treat them separately. They're distinct things, they are separate. Does it matter?
Well, I guess from a functional perspective, no. But if we know there's no duplicates anyway, why would I have the query engine do the additional work to remove the duplicates? I might as well use a union all. And
Precisely. I mean, I think in practice, actually, you probably see more unions than you should, because it's easy and it works and it does everything you need. And actually, the results you get are the correct results. The thing is, if you know there's no duplicates in there and you're running it as a union, yes, it works. And you can say, well, the results of my query are exactly the results. There's no extra rows, there's no rows missing, it's perfect. Mm-hmm. But if you think about logically what it's doing under the covers, it's having to do that quite complex search to go and check for duplicates, and we don't need to do it.
Okay.
So union all should probably be your starting point, and then thinking, well, actually, maybe I need to go do a union here because I do need to check for
Just in
distinctness.
case, all right.
It's in the same way that you don't tend to type select distinct, you should probably veer towards writing union all as your default start point,
Right.
and then you won't be tempted into accidentally writing unions, which the problem is they work.
Right, but
You got
with the
perfect
overhead,
results.
right.
Yeah.
Okay.
So we have a few guidelines. We can't have any queries. I can't say, well, here's 2 queries. I'd like to combine the output from the 2. So we have a couple of guidelines for this. The first thing we've got there is aliases. So we have multiple columns, and those columns are referring to data that's in 2 or 3 or 4 or more tables. Now, because of that, we may well want to alias them. I might not want to have it being called customer name, for example, because it's now got employee information in there as well. So what I would like to do is have an alias for that data. Now the alias, the key thing is the alias is only defined in that first query. So when I've got a query, union, another query, the aliases in the second and subsequent queries basically are ignored. It's all down to the first query. So you set all the aliases up in the first one, and then the subsequent ones you don't need to worry about at all. In fact, if you did put anything, it will ignore it. So that's all done in the first one.
So if I had an expression, for example, which I would obviously want to have an alias, otherwise there wouldn't be a column name, I only need to have the as clause in the first query, and then subsequently it's going to inherit that
Absolutely,
alias.
yeah.
Okay.
Yeah. Number of columns. We can't have a query with 3 columns, union, and then the query with 4 columns. Okay, it has to have the same number of columns. If you do have that data, then you can put an explicit value or a null value in there. So you can enter a null and that would work. You can put an explicit value in and that would work. As long as we're matching them up, they have to end up being the same. And the final thing is they need to be approximately similar data types. So things that we can do an implicit conversion. So we're not saying you can't have a small int and an int, you know, they would be happy with that. It can do that implicit conversion. But if you start having numbers and you start having text, then you need to do an explicit conversion, and you need to use convert or cast to get them into the same data type first, and then you can union them. But make sure that it's essentially similar queries. Really is what you need to generate to union that data.
Okay.
Right, so let's have a look at creating union queries. So we've got a couple of queries here. We want to select the first name and the last name from the employees table, and we want to select the first name and the last name from the customers table. But we don't want to have 2 separate record sets. We want one record set, all of the output in one place. So we could run these independently, and they should work. I mean, you can test these by saying, okay, does this side work? That side works. It's 337 employees, and we can test this side, and this side works. There's 104 customers we've got in there. If we union these two, then we've got 440 rows, which is both the customers and the employees, and anyone who's quick at maths might have worked out that it doesn't quite add up, because if I do a union all...
So hold on, then, before you do the union all, we've done a union.
Mm-hmm.
It's taken the results from the customers table and the results from the employees table.
Yep.
But because it's a union, it behaves the same as a distinct. So if I happen to have a customer and an employee with the same first and last name, I've now only got one copy of that customer.
Exactly,
It's removed the duplicates.
Yeah.
Okay.
So if you'd quickly added up the result numbers, actually we're one out, because
Right.
we don't have enough. But if I do a union all, then we've got 441 rows. So there's one row that occurs in both.
Okay. Let me see if I can use my psychic powers to predict. I think it's a lady, and I think her name begins with a D.
A lady beginning with a D?
A lady beginning with a D and a last name beginning with, it's coming to me.
That would help. We're ordered by last name.
C. Yes, let's try that. Okay.
So if we scroll in here. So no, it's not Campbell. No, not that one. But we do seem to have a Donna Carrera. It's almost as if
it's as if we'd seeded the data to get that result. Yeah. So the point is, we have someone called Donna Carreras, and that's the name of both a customer and an employee, which may or may not be the same person. But okay. So I guess what would be useful then would be to know if we've got those two duplicates, which one is coming from the customer table and which one from the employee table.
So what I'll do is, if I add a literal value, because it may well be that Donna Carreras is a separate person, the customer and the employee may well not be the same person anyway. So we can add literal values. So I'll add one in here saying, well, let's say this one is an employee.
Okay.
Now, worth using, because it's essentially, it's not a calculated column, but it's not being derived from the table, so it's always worth using an alias anyway.
Okay.
I'm not going to call it employee because I'm going to use the same column in the customers table and it wouldn't work for both. So I'll call it type because it's whether
the
they
type
are
of
an
contact,
employee. Yeah. And then we'll do the same here, but the literal value we'll have in here will be customer. So that's customers. Now, as we mentioned before with aliases, I don't need to alias this. You can do, it doesn't hurt because you may think, well, it looks neater and more aligned with the two. It actually won't make any difference. It's going to use the alias from the first query.
So that column's always going to be called type, regardless of how many I'm unioning. Okay.
Yeah, absolutely. They're always going to use that first reference in there. So if we execute this one, now let's do this. We'll start off with a union in here. Mm-hmm. So now we're getting 441 rows. Before we were getting 440.
Because it's distinct, including now this new column. So of course the customer is different from the employee.
It's distinct across all of the columns. So if we scroll down to Donna, what was that?
Carrera. Donna Carrera is her name.
Donna Carrera. There we go. Customer employee, both in there. Because it's not distinct, those are separate to each other. They're distinct. Okay.
But we now know that the result sets from each of these will be distinct because we're explicitly putting in an identifier of our own in there.
Yep.
So I guess from what we said earlier, we're taking a performance hit here because we're using union. We know they're distinct, so why don't we just union all?
Union all. Yeah. I mean, I don't know if it won't be so noticeable if I ran it again because.
That's a small amount of data.
Cache, but actually, I don't know if you noticed, it did take quite a while to run that union query. Certainly a lot longer than that.
Yes.
So yeah,
and we still get our 441 rows.
Same records, faster performance. So always worth defaulting to union all in the same way you default to not using distinct most of the time.
Sure.
And because we said that Donna Carreras might well be a separate person. There's no reason we can't have a customer and the employee with the same name. And we've just stripped them out just for arbitrary reasons.
Great. Okay. Thanks.
We talked about union queries, and we've looked at union all and looking at whether we have records that occur in both queries or that distinct idea of just doing a union and finding ones, removing duplicates. We can do a little bit more with that sort of idea here with using intersect, and then we'll go on to except as well. But intersect, what we're looking at here is only rows that appear in both sets. So here we are looking at overlapping them and saying, okay, we've talked about removing the duplicates. I want to find those duplicates. I want to find the ones that do occur in both. So this is different in that we are explicitly looking for those ones that occur in both of the queries.
Now, conceptually, this sounds familiar, and I can see a Venn diagram oriented vertically rather than horizontally. Mm-hmm. So this is kind of similar to an inner join. But just to emphasize the point that a join is where we're extending the number of columns by bringing columns back from multiple tables. In this case, what we're doing is extending rows, except that because we're using intersect, we're only finding the rows that exist in both data sets.
Absolutely, right. Yeah. So in the join scenario, I couldn't actually add the data from one table to the data from another table in that same column. They would appear as separate rows, separate columns. So here I'm doing it in, that's why we put them vertically, because they appear in that same column.
That result set. Okay.
So that's explicitly looking for those overlapping ones. So we've looked at intersect, they're the ones that occur in both. But what about if we want to look at something that occurs in one record set but doesn't occur in the other record set? So we've got those two again vertically overlapping, but this time we're saying, okay, you are an employee, but I want you not to be a customer. So I want to remove anything that occurs in that other table from the results of the first table.
Okay.
So logically now, if we look at the Venn diagram, we can see that the top table there has had a chunk taken out of it by the bottom table. So if you exist in that bottom table, which in this one is customers, I don't want to see you in the employees set in here. I only want to see employees who are not customers as well.
Right. So that the blue circle represents my employees, the white represents my customers, and where white overlaps blue, we're saying don't include the employees who are also customers.
Absolutely. And the order is, when we were saying before, you were saying about without a join, the order is important. Again, same here, the order is important. If I switch the order of the tables around, then it would be looking at customers who are not employees rather than employees who are not customers. So the order is completely relevant to what you get from there.
Okay, makes sense.
So I just switched to another set of queries. We've got some intersect. So we've already seen that we have a slightly overlapping set of data. We have our Donna sits there as both the customer and the employee. Mm-hmm. So the first thing I want to do, because that just returns to the union, is that we've run this. Let's remove the extra bit of information so that we get back our duplicate. And we've identified that when we run this as a union all, we get 441. We've run this as a union, we get 440. We know there's a duplicate in there. Now, fortunately, I had Graham with me.
And
Graham,
my psychic powers found us.
He knows every single record in that table, and he knew which one it would be. Now, you're not always going to have Graham with you when you do this, in reality. So
you can only hope.
Well, yes. So we do, fortunately, have a means of replicating Graham in SQL code. So what we can do is use this intersect to find what is that overlapping record. Where does it? Because it might be a problem. There might be a reason. Why is that 440, that 441? I'm expecting them to be the same. So when I run this one, we now find, there we go, Donna Carreras listed. So we can, if it's a problem, we've now found that record, and we can say, okay, we can change that, we can deal with that, we can update that record possibly. Okay. The next thing we want to find is those except queries. So now we're saying, well, I want to find customers, but not if they're an employee. I'm not interested, it may be a relevant thing. I want all my customers, but if they're an employee, I'm not going to go out and try and sell them additional products. I just want customers who are not employees in this case. So we're not interested in the Donna Carreras record for customers. We want everyone else. Now, when I run this, we've only got 103 rows. So it's a much lower number of rows because we're only showing the customers. Before we were showing customers and the employees and removing duplicates. Now we're just showing customers and removing, in this case, Donna Carreras from that customer list. So I'm expecting I've got probably I must have 104 customers, but I've removed one because that's...
Well, I was going to say, if you select the first select query and run that, that's all of the customers, we know that, and there's 104 rows, and we know that Donna Carreras is in there.
We're not going to go and search for Donna again, but that's going to be the one. Yeah. So we've now found, removing that one, we've got 103 rows, so we've gone and search. But remember, again, you're getting it to do a bit of work there, so we're having to search through and match up all the records. So it's not something that I want to do just for the sake of doing it. I'd probably want to go and deal with, if it's really a problem, then okay, Donna Carreras needs to be updated to make sure she's distinct in the two.
But there may be, there are perfectly legitimate scenarios where you want to find all the records from one query that aren't in the results from another.
No, exactly. If I'm doing a mail shot to all my customers, I don't really want to mail shot all my employees as well, who just happen to have bought something in the staff canteen. Okay. So we've had a look at union queries. They are very useful queries. They're many situations where you do want to combine the outputs. So we've looked at combining the outputs from different tables, but of course you can use a union query to have the output from the same table as well, which is an example we didn't do. When we talked about top, we might want the top 10%. Maybe I want the sort of key sales. That would be the top 10% and the bottom 20%. Say, well, we could use two top queries sorted in reverse ways, combine the outputs from both, and that comes from the same query. So it doesn't have to be from different tables. So those two queries can be from the same table, and also can be more than one union. So there's no reason we can't keep unioning. And it could well be, another example would be archive. archives are really useful things in databases because they make your working set of records smaller. And if it's smaller, it's faster, typically. And therefore, the things we're not interested in the majority of the time, we can archive that off.
Just a separate table with potentially the same structure.
Well, it probably has. It probably has exactly the same structure. It's archived off. It's not used day to day. We never insert new records in there because it's last year's data. So nothing new goes in there. Nothing gets updated in there. It's all happened in the past. But we now want to run a report over the last 5 years. So what we can do is union all of those yearly records with the current records, and we've got the best of both worlds. We've got a fast working set of data because we're only working with the current year, but also we can run queries on all of the data.
By unioning the other tables.
Absolutely. And if we're doing union, and we're doing a union all and not removing duplicates, then actually it's quite quick as well because it only has to return, it's not doing any filtering, it's just saying return all of this, all of this, all of this, all of this.
And that's a key learning point as well. So if you know that the sets are distinct and you don't want to have the overhead of checking for distinctness, then you just get into the habit of using union all and removing that overhead.
Which is a hard thing to do actually because we always call them union queries.
Yes.
In the same way we call them select queries, we type select, we don't call them select distinct. In the same way. It would be nice actually if it was the other way around and the extra word did the...
Yes, indeed,
the other way around.
And then our intersect and accept queries, again, it's an extension of the same idea, but what it's doing is dealing with those duplicates in different ways, either by finding me which ones are the duplicates, or by eliminating from the first set the ones that are also in the second set. So I can write some pretty sophisticated queries using those techniques.
Yes, and you will. I mean, I think that sort of archive scenario is a real scenario. You do find a lot of people do that. They move their data so they've got a smaller, because as we're going forward, many years ago when I started in IT, it wasn't really an issue. We didn't have much data. Now it's vast. So keeping your current working set manageable, then, but we want to be able to combine it back again. And union's ideal for that.
So there you have it. Union, intersect, and accept. Another way of joining multiple sets of data. This time, the results of multiple queries joined together into one result set. Have a go at the lab for this one. I hope you've already downloaded the lab documents and set up your environment, set up your Azure SQL database. The lab in this one will challenge you with some business problems to return data that brings together results from different queries, and we'll get you to have a go at that. And then once you're comfortable using union and intersect and accept, come back and join us for the next module where we'll look at approaches to aggregating data.